If $4,000 is borrowed at a rate of 6% interest per year, compounded monthly, find the amount owed in 10 years, 20 years, 30 years, 40 years, and 50 years. So basically, we're looking at how much it would cost to pay off a loan if you waited various amounts of time. So because we're dealing with compound interest, we're going to use the formula for compound interest. A of t equals p times 1 plus r over n to the nt power. Now in this situation, the principal is going to be $4,000. The interest rate is 6%. The number of compounding periods, n, is going to be 12. And then t is going to be the quantity that changes. So for each of these values of t, we're going to have a of t equals 4,000 times 1 plus 0.06 over 12 raised to the 12t power. Because p is 4,000, r is 0.06, n is 12, and we don't know what t is. So what we need to do is we need to evaluate this function when t is 10, 20, 30, 40, and 50. So let's look at 10 first. We have a of 10 equals 4,000 times 1 plus 0.06 over 12 to the 12 times 10 power. You can do this on a scientific calculator, so long as you're plugging in everything correctly. You will need parentheses around the exponent so that this whole thing is raised to the product of 12 times 10 power instead of raising it to the 12th power and then multiplying by 10. If you plug everything in correctly, or if you do it all step by step, you end up with $7,277.59. I'm rounding to the nearest cent. So if you took out a $4,000 student loan, for example, that had an interest rate of 6% per year, and you waited 10 years to pay it off, you would then owe over $7,000. Let's see what happens if we wait even longer. Let's look at a of 20. This is going to be 4,000 times 1 plus 0.06 over 12 to the 12 times 20th power. And when we calculate this, we end up with $13,240.82. So the lesson that we're learning, hopefully very quickly, is that if you don't start paying off your student loans very quickly, they can double or triple in how much you owe over the course of 10 or 20 years. But let's continue. Let's look at what happens when we wait 30, 40, or 50 years. If we wait 30 years, the only thing that's changing here is the value of t, which goes at the very end. If we end up waiting 30 years, then this ends up costing a total of $24,090.30. The reason it's getting bigger and bigger and bigger is because the interest is being compounded. So every time you owe interest, that goes into the amount that you owe, and then you owe interest on top of that, and then you owe more interest on top of that, and it keeps getting bigger and bigger, and scarier and scarier. Let's take a look at 40 years. Again, nothing changes except the value of t. which goes in the very end of the exponent. And when we change from 30 years to 40 years, do you want to take a guess how much it's going to be? Well, in the end, it is $43,829.81. And if we wait 50 years, well, maybe we'll be dead then and we won't have to pay anything, but let's do the calculation regardless. Let's see, 12 times 50 in that exponent. And when we do the calculation, we end up with $79,743.82. Yikes. So there's two things that are really important for me about this problem. The first is, as far as students getting practice, I really want everyone to make sure that they're entering all of this into a calculator and getting the right values. Because what tends to happen is students just sit there and they let the teacher do the calculations. Why should I spend the time doing the calculations? But the reason is students make loads of mistakes when they're entering things into calculators. Sometimes when I ask students to do a calculation like this, 80% of them get it wrong because they didn't type things incorrectly. So this is a situation that you really need to use to make sure that you're entering these things incorrectly. Because if a test comes and you enter it incorrectly and you get it wrong and you can't figure out what your mistake was, you really have nothing that you can do. So we want to get practice now while we're not under testing anxiety to make sure that we understand how our calculators work. The other thing is that interest grows exponentially. We've seen the graphs of exponential functions, and we know that the more time passes, the steeper it gets, the faster it increases. And so when we wait these first 10 years, we owe an extra $3,300. But if we wait 50 years, all of a sudden we're owing $75,000 extra dollars. So this goes up, 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 and we have to be extra careful. The upside of this is if we were looking this as an investment problem instead of a loan problem, if we were investing money, then you can see how compound interest makes it grow faster and faster the longer it's been in. This is why many people suggest putting money into savings accounts and into other investments very early on in your life, because the longer that interest compounds, the more money you end up getting.